Hello guys, welcome to the first session of the online Arduino workshop by IEEE. So let's get started. What exactly is an Arduino? The term Arduino is used to represent so many different things and is often confusing. So let's get down to it and see what an Arduino actually is. This is a microcontroller. A microcontroller is actually an integrated circuit, or IC for short, that is basically a small computer. Microcontrollers are low powered enough such that it can run on a single battery for many days, but it is still faster than a human mind in terms of data processing. Microcontrollers can run small software programs. Arduino is an Italian company that creates and sells circuit boards that helps us to program these microcontrollers. Historically, for coding microcontrollers, we had to remember so many binaries and hard to remember registers and instructions. We also had to use specialized hardware for uploading the code. So what the Arduino company did was they created a circuit board. It could be connected to any laptops or PC via the USB cable port. They also created an IDE which we installed in the last video. So in this IDE, we can actually type our logic which is to be implemented by the microcontroller in a language similar to C. After writing our logic, the Arduino IDE converts the code into machine level language which the IC can understand, and we can upload it with the help of a USB cable and the click of a button. So the circuit boards that the Arduino company created are called Arduinos. There are different types of circuit boards, but most probably when we are referring to Arduino, it is a circuit board called Arduino Uno. Calling an Arduino a microcontroller is technically incorrect because it's a circuit board that houses the microcontroller, but it also has a lot of other stuff too. So let's explore them one by one. This is the microcontroller part of the Arduino Uno board. The Arduino Uno has a microcontroller named Atmega328P. It has 14 digital input or output pins, out of which 6 can be used as PWM outputs, which you will be learning more about later. You can say that this microcontroller part is actually the brain of the Arduino board, as this is where the code we type gets executed. We do have another microcontroller on the Arduino board. This microcontroller helps us to upload the code into the main microcontroller, and once uploaded, this helps us to send messages back and forth between the computer and the microcontroller. Another advantage of the Arduino board is that you can power the board with the help of a laptop or PC via the USB cable, or if you don't want it to stay connected to your laptop, you can always attach a battery to it. This is the reset button of the Arduino board. If pressed while running a program, it momentarily stops the program and starts it all over again. And now, let's look at the pin connectors on the board. First, we have the power pins. You can connect other circuits to these pins, and it will supply 3.3 volts or 5 volts depending on what pin you are connecting it to. Next is the TX and RX pins. With these pins, you can send and receive data from different modules such as the Wi-Fi module, the GPS module, or the Bluetooth module. Pins 2 to 13 are for digital inputs and outputs. These pins can either produce 5 volts or 0 volts. This is similar to the binary system of zeros and ones, the one being 5 volt here. In addition, these pins can actually expect a voltage and evaluate whether the given voltage is a 5 volt or a 0 volt. So in total, there are 3 states for these pins. The first one being producing a 0 voltage or being in the off state. The second one is producing a 5 volt. The third one is receiving a voltage from the connected pin. In many cases, we will have to work with voltages in between the minimum and the maximum levels. That is between 0 volts and 5 volts. So here we have 6 analog input pins which can identify voltages in between 0 volts and 5 volts. We will be learning more about these pins in the coming session. So I hope you learned a little bit about the Arduino Uno's architecture, and we will be learning more about how to use them and how to program an Arduino in the coming sessions. So let's move on to the next section, the breadboard. In the electronics field, we'll have to reuse the same component for different projects. This means that we can't go on soldering every component or use any other permanent joining technique for connecting two circuit elements. This is where the breadboard comes in. The breadboard is actually construction based, where you can connect two elements just by inserting them into each holes. As you can see here, this is how each of the holes in the breadboard is actually connected. You can see that on the top and on the bottom, the entire row of holes are connected. So if you connect a 5V pin from the Arduino in this hole, you will actually get a 5V in all of these holes, and you can connect multiple elements and they all will get 5V each. But the inner pins are a bit different. They are connected column wise. So if you connect a wire here and you connect another circuit element here, they are automatically connected with the help of a breadboard. So with the help of a breadboard, you can easily connect two circuit elements together, and those circuit elements doesn't need to be soldered together and can be reused as many times as we want. I hope the concept of the breadboard is clear to you. We'll be using the breadboard in the coming simulations for connecting two circuit elements so that you will get a clearer picture. Thank you for watching.